Hello viewers, my name is Mr. Adebanjo. Welcome to my channel. In this video, we are going to be rubbing minds together on coordinate geometry. That is to say, we are going to be discussing coordinate geometry in this video. Coordinate geometry is one of the topics that is very important in general mathematics and further mathematics topics. So whether you are a further mathematics student or general mathematics student, you need to understand coordinate geometry. Even the JAM question also, there are a lot of questions on the coordinate geometry in JAM questions. So whether you are a general mathematics student or a further mathematics student, like I've said earlier, you need to understand coordinate geometry. The topic is very simple, as you are going to be seeing it shortly. So what are we going to be doing in this video? And those topics you are going to be discussing under coordinate geometry. One of them is we're going to be telling you the meaning of coordinates, and also we are going to be using finding distance between 2 points, given the coordinate of the 2 points. We are also going to be talking about the midpoint of 2 points, given their coordinates as well. And also we are going to be finding the gradient of straight line in different forms. And also we are going to be finding the equation of straight line also, given the coordinates of 2 points that the line passes through. And also we are going to be talking about the parallelism and perpendicularity of straight lines and their implication also. And also we are going to be talking about angles between two straight lines. And we are going to be, for each of these subtopic we have under this coordinate geometry, there are going to be evaluation questions that could help you to evaluate yourself whether you understand each of the topic or not. And like I told you, I'm going to be explaining each of these subtopic as easy as it's going to be, so you don't have anything to be scared of. The topic are very simple, and all you need to do is to pay attention, get your writing materials and your biro and your paper, and let's start the journey of coordinate geometry proper. And but before we get it started, if you are yet to subscribe to this channel, please click the subscribe button on the channel right now, and by so doing you help us improve this channel. And don't forget to share this video with a student out there who need these resource materials, whether for WAEC, JAMB, NECO, and other examination. How there you need to understand the coordinate geometry. So let's jump into the discussion proper. Now, the first thing we want to talk about is what is coordinates, or what are coordinates? What is coordinate, and what are coordinates? Before we talk about the topics that we have under coordinate geometry, you need to have perfect understanding of what coordinate is all about. And if you know what coordinate is all about and where we can get coordinate from, then you have no problem in understanding this topic, as we are going to be talking about shortly. So the question is, what are coordinates, or what is coordinates? Now, coordinates are numerical values that define the position of a point or an object in a space, usually in relation to a specific reference system. I come again, coordinates are numerical values that define the position of a point or an object in a space, usually in relation to a specific reference system. So I'm going to be giving you the definition in a layman definition that you could understand easily. So when we are talking about coordinates, coordinate is talking about the value of any point or an object in relation to the axis of the axis of the graph we are working on. Now, because we are going to be using graph in this on this topic, that's why I'm using the reference system, which is graph. So we are talking about in relation to a specific reference system, but in this case we are going to be referencing graph. So I will say coordinates are numerical values that define the position of a point in reference to the axis of a graph. So coordinates are numerical values that define the position of any point or an object in relation to the axis of the graph. So I'm going to explain better on that when we get to the graph page, so that you can understand what I'm trying to say. So we have different types of coordinates. There is a Cartesian coordinate, which is what this video is based on. Cartesian means graph. Cartesian means graph. We are going to be working on this type of coordinate, which is Cartesian coordinates. We still have a polar coordinate. We are not going to be working on this because this is not the scope of this video. We have geographic coordinates, and we have spherical or cylindrical coordinate as well. So, but this video is based on Cartesian coordinates, which is coordinate that is gotten from the graph. Do we understand that now? So, coordinate that we are going to be working on is related to Cartesian, which is talking about graph. So now let's try to understand what coordinate is all about. Now, if you look at this screen right now, you can see that we are having a graph on the screen right now, and probably let me zoom in a little so that we can see. So of course you can see that this is a graph. It's obvious that this is a graph. Or can't you see? I believe you can see that this is a graph. So this is a graph. Let me zoom in a little so that you can see very well. Okay, we are having a graph here, and on the graph we are having y-axis, and the scale is 2 centimeters to represent 2 units, and also we are having x-axis as well. Yeah, so and the scale is 2 centimeters represent 1 unit. So I just want you to see that this is a graph, and there is what you might have seen one way or the other. And on this graph you can see that we have some lines which are vertical, and those are y-axis. They are y-axis, and there are some lines that are horizontal. Those are x-axis. So now what coordinate is talking about is that imagine I put a point here now where I'm putting this hand. Let's say there is a point here, or an object is here now. You agree with me that this object is falling upon a line of x-axis, and it also falling upon a point on the y-axis. If I put a point here now, this point which is here is falling upon this line which is going to the x-axis here, and it's falling upon this line here which is referencing the y-axis as well. So coordinate is talking about the position of any point in relation to the x-axis and the y-axis. So if I also put another object here now, that means that object is falling upon a particular line of x-axis, another line of what, y-axis. If I put another object here, that object will reference a line of x-axis here, a line of y-axis here. So quickly let me zoom out again and let us see. So now look at the graph here now. Like as I said earlier, I'm trying to define what a coordinate is all about to us. That coordinate is talking about the relation or the position of any object in relation to the y-axis and x-axis. And if I put an object here, let's put a point here. Okay, you can see this point here that I'm highlighting on. This point here, you agree with me that this point, which you can call point A, if I call it point A, this point here, this black this dot is now, let's call it point A. that point A is on the x-axis and it's on 1 on x-axis, and on y-axis is on 2. So that means if the value of this point A on the graph is an is on the 1 on x-axis and on the 2 on y-axis. So if I now write this value in a curve bracket, and I write it as a like this 1 comma 2, saying that this point A is on x-axis is on 1 and on y-axis on 2. So this written in a bracket is called a coordinate. So the value of this, the position of point A on the graph is on the x-axis 1, on y-axis on what 2. So if you now write this value in brackets form like this, separated by comma, this is called a coordinate. So A is on x-axis 1, on y-axis on 2. So this is what we call coordinate, the location or position of a point or an object in relation to the axis of the graph. So this is x and y coordinates. That is 1 represent x, 2 represent y. And look at the arrangement. X always come before y. It is x and y coordinate. So the coordinate of point A is 1, 2. So let's see another point. Let's assume there is another point here. Let's assume there's another point here now, which is highlight this black dot here. So can you tell me the coordinate of this point? This, let's call it point B. So let's call this point B. Can you tell me the coordinate of point B? So B is on 5 in x-axis. Is 5 on x-axis. Then on y-axis is on what? 4. So the coordinate will be 5, 4. So the coordinate of point B will be 5, 4 in this case. Do we understand that? Let's see another point. Let's say there's another point here now, you can see. And can you tell me the coordinate of this point? Let's call it point C. Can you tell me coordinate of this point C? Let me give you 1 second to figure that out. This is on the x-axis we are having -3, and on the y-axis we are having -2. So can you tell me the coordinate of can you write down the coordinate of point C? So point C is on -3, -2. On the x-axis it is -3, on the y-axis is on -2. So the coordinate of point C is -3, -2. So let's see if there's let's see, look at this point now. Let's say there's another point here. Let's call it the point D. So can you tell me the coordinate of point D? Please figure that out quickly so that you can help you confirm whether you're right or wrong. On the x-axis, what is the coordinate? What is the value of point D? On the x-axis here, which is -5. On the y-axis, which is 4. So that means the coordinate will be -5, 4. Don't forget, in writing out coordinate of a point on the graph, x come before y. It is x and y coordinates. So when you write the value of a point on the x-axis and the value of that point on the y-axis, you now put it in a bracket separated by comma, and that you are talking about coordinates. So coordinate is talking about the location of a point or an object in relation to the axis of the graph. I hope you understand that now. So by now you should be able to find the coordinate of any point on graph now. So if I say there's a point here now, that means you should be able to find the coordinate of that point here. That should be -1, 2. If I say there is a point here, for example, let's say there's a point here now, you should be able to get me the coordinate of that point here. That should be on the x-axis. What will be the value on the x-axis? What will be the value of this point? That will be 3. On y-axis, that will be 6. So that means you have 3, 6. So you should be able, as a student, to get or identify the coordinate of a graph, also of a point on a graph. And don't forget, you can't get a coordinate outside graph in this context. So that means I can only get coordinates on a Cartesian graph or on our graph based on the first type of coordinate that we have. So have you understood how we can how to get coordinate from graph? And there are a lot of things we can do with this coordinate that we have identified. For instance, now if there is a straight line that join this point A and point B together, I should be able to find the distance between the 2 points. For instance, if there is a straight line that passes through this point A and point B, I should be able to find the gradient of that straight line and so other things. So you'll be discussing other subtopic under coordinate geometry, knowing fully well that we can only get coordinates on this Cartesian graph. So definitely, whether we draw graph or we don't draw graph, when you are given coordinates to work on, so you should have it at the back of your mind that you are indirectly working on graph, whether you draw the graph or you don't draw graph. So you are indirectly working on graph because we can only get coordinates from graph. Am I making sense? We can only get coordinates from graph because coordinate is talking about the location of any point or any object on graph in related to the axis of that graph. Do we understand that now? Good. So if you understood that, please just try your on using this graph on the board. So on this screen right now, just this point here that I'm pointing out, then tell me the coordinate of that point. Then also here where I'm highlighting here also, I want you to pause the video and tell me the coordinate of that point as well. This point here where I'm highlighting on. Then one more, the last one, I want you to, this point where I'm touching as well, I want you to tell me the coordinate of this point as well. I want you to drop the answer in the comment section of this video and I will respond to that, so as to help you understand what coordinate is all about. Now, having understood how to get coordinate or what coordinate is all about, the next thing to talk about is the distance between 2 points given their coordinates. That is to say, we should be able to find the distance between any 2 points on the graph when we know their coordinates. Whether we draw the graph or we don't draw the graph, once we know the coordinate of 2 points on the graph, we should be able to find the distance between those 2 points. Now, for example, look at this graph. I have the y-axis, I have the x-axis. So let's assume that this is our graph. Excuse me. So let's assume that this is our graph. Now, if I have a point here, let's say point A, and the coordinate of point A is x1 and y1. So that means the value of this point A on the x-axis is going to be x1. And the value of this point A on the y-axis will be y1 as well. So don't forget that the coordinate of point A is x1. That means the value of this point here is x1, and the coordinate of the value of point A on the y-axis is y1. So that gives us this coordinate to be x1, y1. Are we there? So let's say there's another point here which is point B. So because this is a graph as well, that means point B also will also have a value on the x-axis, which is s2. That will be s2, and the value point B also will also have a value on the y-axis. That will be y2. So that will be y2. So what we are trying to say in this topic is that we should be able to find the distance between point A and point B when we know their coordinates. So we should be able to find the distance between point A here and point B here when we know their coordinates. So how do we find the distance between 2 points on the graph given their coordinates? So we agree with me that the distance between point A and point B will be the straight line that is joining them together. That will be the length of this straight line joining point A and point B together. You agree with me? Good. So now if you can find the length of this straight line that join point A and point B together, that will give us the distance between them. So how do we go about that? We can form a right angle triangle with this straight line. So and draw a straight line here, another one here. So that will give us a right angle or triangle. Do we understand that? So our aim is to find the distance AB, which is the distance between point A and point B, knowing their coordinates. Then all you need to do is to form a right angle triangle with that straight line. Then we can find the distance between this point and this point here. So of course, what's the distance between this between here and here of that triangle? From here, this we can tell us the distance. We can find the distance from here to here. That should be s2 minus x1. Whatsoever you have here minus whatever you have here, that will give us the length from here to here. And also we can find the distance from here to here, from y2 to y1 as well, which is same thing as from here to here. So that should give us the value of a y2 minus y1. If this is 5 and this is 2, so distance from here to here will be 5 minus 2. So that will be y2 minus y1. Do you understand that? Good. So if you understand that, and you understand the principle that that is around a right angle triangle, that when we have two sides of a right angle triangle, looking for the third side, what principle can we use? We can use Pythagoras theorem. So in this right angle triangle, we have this side, we have this side. We are looking for this side, which is the length. This is the distance between point A and point B. So you can use Pythagoras theorem to find that. Using Pythagoras theorem, so we have that the square of the hypotenuse side, which is AB square, equals to the square of the remaining two sides added together. So that will be AC square plus BC square. So this is Pythagoras theorem. So from there, our aim is to find the distance between A and B. So that will be AB square equals to, our AC is S2 minus S1. So that should give us S2 minus S1 squared. That will be AC then square S2 minus S1 squared plus then BC is Y2 minus Y1. That will be Y2 minus Y1 squared. So our aim is to find AB, not AB square. So we need to get rid of this square. So all you need to do is to take the square root of both sides. So that means side AB will be equals to length AB, side AB will be equals to square root of S2 minus S1 squared plus Y2 minus Y1 squared. So that means if I want to find the distance between A and B, I will use the square root of change in X squared plus change in Y squared. What do I mean by change in X and change in Y? Change in X means S2 minus S1, and change in Y means Y2 minus Y1. So if I want to find distance between 2 points, given their coordinates, if I want to find distance between 2 points, given their coordinates, that is, I'm giving the two coordinates of 2 points, I'm giving coordinate of 2 points, and I'm also find the distance between those 2 points. All I will need to remember, I need to remember this formula, that S2 square root of S2 minus S1 squared plus Y2 minus Y1 squared. So if anytime you want to find the distance between 2 points on the graph, given their coordinates, so you can use this formula to find the distance between them. So of course, you don't really need to know what you are having here. All you need to remember is that the distance between 2 points, given the coordinate of the 2 points, is the square root of change in X square plus change in Y square. So you must remember this formula. That's why I'm trying to re-emphasize on that. To find the distance between any 2 points, given their coordinates, you need the square root of S2 minus S1 squared plus Y2 minus Y1 squared. Do we understand that? So let's use that to solve some questions. So example 1, you have to find the distance between point X, given the coordinate of X to be S3, 2, and the point Y, given the coordinate of Y to be 4, 6. So you have to find the distance between point X and point Y, and we know the coordinate of the two of them. So how do we do that? Then we need to remember that the distance between X and Y, because we are looking for X and distance between X and Y now. So we have distance xy to be square root of S2 minus S1 squared plus Y2 minus Y1 squared, which I believe you know. Remember this formula. This is the formula for finding the distance between 2 points, given their coordinates. Do we understand that? So where are we what will be our S1, what will be our S2, what will be our Y1, what will be our Y2? So this is the first coordinate here. So from here we'll get our x1, y1. So s1 is 3, y1 is 2. From this coordinate we get our s2, y2. s2 is 4, y2 is 6. So don't forget that this x and y coordinate x and y coordinates. So the first coordinate here, you have x1, y1, s2, y2. I believe you understand that now. So if you now substitute that into this formula, so therefore the distance between between x and y will be equals to the square root of our s2 is 4. You put 4 here, minus our s1 will be what, which is 3, minus 3, then squared, plus what's our y2? Our y2 is 6, minus our y1 is what, 2. So we have minus 2, then squared. Do you understand that substitution that I made? What's our s2? Our s2 is 4. Our s1 is what? Our s1 is 3. So we have 4 minus 3, then squared, plus what's our y2? Our y2 is 6, and our y1 is 2. So we have 6 minus 2 squared. So if you simplify that further, 4 minus 3 give us 1, then we have 1 squared, plus 6 minus 2 give us 4, you have 4 squared. Then therefore 1 square will give us 1, plus 4 square will give us 16. Then 1 plus 16 will give us 17. So we have the square root of 17 to be the distance between x and y in units. So the distance between x and y is 17 units. The distance between x and y is 17 units. So that is one way of one way of using that formula to find the distance between 2 points. Let's see another one. Example 2. We have to find the distance between point A and point B, given their coordinate also. You are given the distance. You have to find the distance between point A and point B. The coordinate of the coordinate of A is minus 3, minus 2, and the coordinate of B is 1 and minus 4. So we have to find the distance between them also. So we need to remember the formula for finding the distance between 2 points. That will be square root of s2 minus s1 square plus y2 minus y1 square as well. So from this first coordinate, you get your s1 y1, s2 y2, and if you substitute that into this formula, you'll be having distance AB equals to square root of s2 is 1, so you have 1 minus our s1 is minus 2, so you have a open bracket minus, sorry, our s1 is a minus 3 rather, open bracket minus 3, close the bracket, then this bracket, close it again, then squared, plus our y2 is minus 4, you have minus 4 minus our y1 is a minus 2, so you have open bracket minus 2, close the bracket, then close the big bracket, squared. Then from there, you need to simplify further. You open this bracket, minus times minus will give us plus. Also here, minus times minus will give us plus also. So if you simplify that further, you'll be having plus 1 plus 3, that gives us 4. You have 4 squared. Then plus minus times minus here will give us a plus also. You have minus 4 plus 2, that gives us a minus 2, then squared. So from there, if you simplify that further, 4 square will give us a 16, plus minus 2 square will give us a 4. So we have a 16 plus 4, that gives us a 20. So you have square root of 20. And if you understand the sword very well, you can simplify this sword further. If you simplify that, that will give us a sword 4 times 5. And sword 4 is 2. So that will give us a 2 sword 5 units. So that means the distance between point A and point B is 2 sword 5 units, which I believe you understand sword. But if you don't understand sword, please check the video on my channel where I explain sword from the beginning to the end. So we are still talking about how to find the distance between 2 points. We have gotten the distance between point A and point B to be 2 sword 5 units. Let's see another question. Another example here is that you have to calculate the length of the line joining P to Q. You have to calculate the length of the line joining P to Q. You have to calculate the length of the line joining P to Q, and P has a coordinate of minus 3, 4, and the Q has a coordinate of 5, minus 2. So you can pause this video and try to find the distance, the distance between point P and Q, knowing fully well that the distance between point P and Q is same thing as the length of this line that join them together. So the length of the line that join P and Q together is still the same thing as the distance between point P and point Q. So if I find the distance between P and Q, I'm still is still the same thing as the length of the line joining them together. So I want you to pause this video and try to solve it yourself and see what you're going to get. Then play the video again and compare your answer with what you got here. And I believe you have done that. Then the distance PQ will be the square root of s2 minus s1 squared plus y2 minus y1 squared. So now from from the first coordinate we get our s1 y1, and from the second coordinate we have a y2 sorry s2 y2. So from there, what do we do? If you substitute your answer here, our s2 that will be 5, and our s1 that will be minus 3. So we having 5 minus open bracket minus 3 then squared plus our y1 our y2 that will be minus 2, and our y1 that will be 4. So we'll be having minus 2 then minus 4 then squared. I believe you understand that substitution. Then if you simplify this, minus times minus will give us a plus. So this should give us a 5 plus 3, that give us 8. So you'll be having 8 squared here. So you'll be having square root of 5 plus 3 squared. Then plus minus 2 minus 4 give us minus 6, then squared. So if you simplify that further, that will give us a 8 squared will give us a 64. Then minus 6 squared will give us a 36. So because minus 6 times minus 6 will give us a plus 36. So if you 64 plus 36 give us 100. So you have the square root of 100. So that should give us the square root of 100. That give us 10 units. So that means the length of the line joining P and Q together is 10 units, which is the same thing as the distance between point P and point Q. So we are still using the same formula for finding the distance between 2 points together. So, and I believe you understand what you have done. So let's see another example on that. Now this question is an indirect question. We have to find the value of r if the distance between the points, this point and this point, is 3 units. So we have to find the value of r if the distance between the point this and this is 3 units. So this is an indirect question, and this question could be is given in a JAMB question. For those that are writing JAMB, it's still similar to what you have been doing so far. So let's see the question solution. You are given that they are giving this two coordinate, this coordinate and this coordinate, and they told us that the distance between them is 3 units. So that means I will see you use the distance between 2 points, which is going to be square root of change in s squared plus change in y squared. So you have been given the distance with the value of the distance between them, that will be 3 units. So you have 3 is equals to square root of, what's our s2? Our s2 is 1 minus, what's our s1? Our s1 is 4. So you have 1 minus 4 squared plus, what's our y2? Our y2 is r. So you have r minus, what's our y1? That should be 2. So we have r minus 2 squared. Do you understand that? Then if you simplify that further, we have 3 equals to 1 minus 4 give us minus 3. Then you have minus 3 squared plus r minus 2. We can't subtract that. So r minus 2 remains r minus 2. So we have r minus 2 squared. From there also, we can find what is the square of minus 3. That will give us 9. So we have 3. We have 3 equals to square root of 9 plus r minus 2 squared. So we can get rid of these square roots. What can we do to get rid of the square roots? We can square both sides. So if you squared everything here and you square this 3, so you can get rid of this, you can cancel the square roots by squaring both sides. Square both sides to get rid of this square. So if I square 3, I'll get 9. If I square everything here, that will take care of the square roots. So minus 3 square will give us 9, then plus r minus 2 square, which is what you're having here. Do we understand that? Good. So from there, what can we do? We can collect like times. Now come here. So we'll be having r minus 2 squared equals to 9 minus 9. So 9 minus 9 will give us 0. So you'll be having r minus 2 squared equals to 0. So r minus 2 squared equals to 0. So, and now, how can I remove this square? We need to find the square root of both sides. So if I find the square root of both sides, so the square root of this will take care of the square here, and the square root of 0 give us 0. So you have r minus 2 equals to 0. Then collect like times here, so r will be equals to 0 plus 2, that give us a 2. So that means our r is equals to 2. So we can see how to use formula for finding distance between 2 points to solve indirect question. In this case, we are not finding distance. We are not finding distance here, but we are using the formula for finding distance to get the value of this r, given the distance between these two coordinates, which is what we have done here. So this question is a jump question, so which I believe you understand. So let's see one more example on this. We are to find the value of alpha squared plus beta squared if alpha plus beta is equal to 2 and the distance between the points 1, alpha and the beta, 1 is 3 units. So you can see another question that you could be asked, most especially for the mathematics student and the JAM student as well. We are to find the value of alpha squared plus beta squared if alpha plus beta is equal to 2 and the distance between the point this and this is equal to 3 units. Why is this question related to the topic we are talking about now? This is where it this from here, the distance between this and this, and don't forget that this one and this is they are coordinates. So we have 1, alpha and a beta, 1. These are two coordinates, and they said distance between them. So that is why this question is related to what we are talking about. So we have been given the distance between these 2 points, which is 3. So then we have to get the value of alpha squared plus beta squared, giving alpha plus beta equals to 2. So let's see that in action as well. Of course, we need to forward get the distance between 2 points. Distance between 2 points, you need to remember the formula also. S2 minus S1 squared plus Y2 minus Y1 squared. Then from these two coordinates, you should know your S1, you should know your Y1, our S2 and our Y2. So, and the value of the distance between them is 3. So the distance between them is going to be 3. So we'll be having 3 is equal to the square root of our S2 is beta. So you have beta minus our S1 is 1. So you have beta minus 1 square plus our Y2 is 1 minus our Y1 is beta. So our Y1 is alpha rather. Our Y2 is 1 and our Y1 is alpha. So you have 1 minus alpha squared. Do we understand that? What can we do from there? We can get rid of this square root by finding square of both sides. Take the square of both sides. If I take the square of 3, that gives us 9. If I take the square of this side, that will eliminate the square root. So we are left with a beta minus 1 squared plus 1 minus alpha squared. So what do? We can expand this bracket, expand this bracket. So that should give us 9 is equals to this bracket in 2 places and plus this bracket also in 2 places like this. So we can now expand this bracket. So we'll be having 9 is equals to beta times beta give us beta squared. Beta times minus 1 will give us minus beta. Minus 1 times beta will give us minus beta. Minus 1 times minus 1 will give us plus 1. Also, we can expand this bracket as well. 1 times 1 will give us 1. 1 times minus alpha will give us minus alpha. Minus 1 times alpha will give us minus alpha. Minus alpha times minus alpha will give us a plus alpha squared. From there, we can collect like times 9 is equals to, it can bring alpha and beta, alpha squared and beta squared together. That gives us alpha squared plus beta squared minus alpha minus beta minus beta. That gives us a minus 2 beta. Then minus alpha, that gives us minus 2 alpha. 1 plus 1 will give us 2. Do we understand that? Good. You can collect like times here. So if you collect like times, we have 9 is equals to alpha square plus beta square. We can factorize minus 2 here. Minus 2 is common to this and this. We factorize minus 2. You have minus 2 into bracket alpha plus beta. So I've rearranged this one. It's supposed to be minus 2 into bracket beta plus alpha, but you can have beta plus alpha is same as alpha plus beta. So it's minus 2 into alpha plus beta plus 2. Do we understand that? So we are giving the value of alpha plus beta. They said that one is 2. So if you substitute that here, you'll be having 9 equals to alpha squared plus beta squared. So we have minus 2 times the value of alpha plus beta is 2. So we have minus 2 times minus 2. sorry, minus 2 times 2 rather, because alpha plus beta is equal to 2. So minus 2 times 2 plus 2. So if you simplify that, minus 2 times 2 will give us a minus 4. Then minus 4 plus 2 will give us a minus 2. So you'll be having 9 equals to alpha square plus beta square minus 2. Then take 9 minus 2 to this side. So you'll be having alpha square plus beta square to be 9 plus 2. And that will give us 11. So the value of alpha square plus beta square is going to be 11, which is the solution to that question. So this is a JAMB question also, and it could also be a further mathematics question. So which I believe you also understand how we solve this using the distance between 2 points, given their coordinates. Now, if you understood what we have done so far under a distance between 2 points, please, I want you to attempt these 2 questions. So these 3 questions. You have to calculate the distance between L and M, distance between this and this, and you have to find the length of the line joining this and this. So I want you to drop the answer of answer in the comment section of this video, and I will relate to that. The next thing on our agenda is the next topic is midpoint of 2 points given their coordinates. That is to say that having talked about distance between 2 points, we should be able to find the middle of 2 points given their coordinates. Now, we have talked about how we can find the distance between any 2 points on the graph given their coordinates. Then the next thing we want to talk about is how we can find the midpoint, the middle of any 2 points given their coordinates. Now, also assuming that this is a graph as well, having y-axis and x-axis as well, then and we have a point A having coordinate of s1, y1. So knowing that the value of A on the x-axis is s1 and the value of A on the y-axis is y1, and there's another point also which is point B. The value of B on the x-axis is s2 and the value of B on y-axis is y2. And also the line joining them together is this straight line, which we can find the distance between these 2 points, point A and point B, which is what we have talked about in the previous slide. We should be able to find the middle of point A and point B. That is what midpoint is saying. We should be able to find the middle of point A and point B, and that is what the midpoint of 2 points. Don't forget that the 2 points are point A and point B, but we are looking for the midpoint, which is the middle of point A and point B. So assuming that the midpoint of A and point B is P, let's call it P, which is the midpoint of A and B, and we believe that this point P as well, which is the midpoint, the middle of A and B, is going to have its own coordinates. It's going to have its own coordinate. That is this point P will have a value on the x-axis and a value on the y-axis. So let's assume that the coordinate of point P is s, y. That is, the value of P on the x-axis is going to be x, and the value of P on the y-axis is going to be y. So don't forget that this P is the midpoint of point A and point B. That is middle. You know the meaning of middle, midpoint. So this point P will also have its own coordinates to be x and y, s, y. Then the question is, how do we now get the coordinate of this midpoint of A and B, which is P? Now, to get the midpoint of any 2 points, all we need to do is to add the s2 in this second point plus the x1 in the first point. We now divide it by 2, comma, then the y2 plus y1 here divided by 2 will give us the coordinate of the middle or the midpoint of the 2 points. What am I saying in essence? Although there are other principles we need to apply to get this, but we are not going to talk about that. So it means that if I want to find the midpoint of any 2 points given their coordinates, all I need is that to add s2 to plus s1 over 2, comma, y2 plus y1 over 2. So technically, the midpoint of 2 points will give us another coordinate. So midpoint of any 2 points is gotten by using this formula, s2 plus s1 over 2, comma, y2 plus y1 over 2. So with this formula, we can find the midpoint of any 2 points on the graph. Am I communicating at all? Do you understand? So let's use that to solve an example, some question also. So to calculate the midpoint of 2 points, so you have to calculate the midpoint of P and Q. You have to calculate the midpoint of point P and point Q. So we are given the coordinate of point P to be minus 3, 4, and the coordinate of Q to be 5, minus 2. So we have to find the midpoint of those 2 points. So don't forget that the midpoint of PQ will be s2 plus x1 over 2, y2 plus y1 over 2. So from here, we know that this will be our s1, y1, our s2, y2. So we can easily substitute into this. Our s2 is 5 and our s1 is minus 3. So that means you'll be having 5 then plus then minus 3 over 2, comma, our y2 is minus 2, our y1 is 4. So we'll be having minus 2 plus 4 over 2. So if you simplify that for further, plus times 1 will give us minus. So you have 5 minus 3 over 2, comma, minus 2 plus 4 will give us 2 over 2. So 5 minus 3 will give us 2. So we'll be having 2 over 2, which is going to give us 1. Then 2 over 2 also give us 1. So that means the midpoint of point P and Q is 1, 1. Do you understand that? The midpoint of point P and point Q is 1, 1. So a student should have it at the back of his mind that if I'm finding the coordinate of, if I'm finding the midpoint of any 2 points, it's going to give me another coordinate. So the answer I'm going to get is going to be coordinate compared to that of distance between 2 points. When you found the distance between 2 points, we got a unit value. We didn't get a coordinate. But if you are looking for the midpoint of 2 points, you are going to get a coordinate as your answer. Let's see another example. Example 2, you have to calculate the midpoint of the line joining C, having coordinate of 4, 4, and the point D having coordinate of 2, minus 6. So of course, it's still very simple as well. All you need to remember is to remember the formula for finding the midpoint of 2 points. So the midpoint of CD, or that is point C and D, is we see how the same formula, s2 plus s1 over 2, y2 plus y1 over 2. This is our s1, y1, s2, y2. So if you put s2 is 2 plus s1, which is 4. So that gives us 2 plus 4 over 2. Our y2 is minus 6. Our y1 is 4. So that gives us minus 6 plus 4. So from there, you'll be having 2 plus 4 over 2, comma, minus 6 plus 4 over 2. 2 plus 4 will give us a 6. 6 divided by 2. So we have 6 over 2 here, comma, minus 6 plus 4 will give us minus 2 over 2. So 6 over 2 will give us 3. Minus 2 divided by 2 will give us minus 1. So it means that the midpoint of CD is going to be 3, minus 1, which is another coordinate, which is the coordinate of the midpoint of point C and point D. Let's see another example. You have to find the midpoint of the line joining point E and point F, giving the coordinate of E to be P, 0, and the coordinate of point F to be 0, Q. So you have to find the midpoint of this point E and point F. Also, we know the formula for finding the midpoint. We have this. So our S2 is 0, and our S1 is P. Our Y2 is Q, and our Y1 is 0. So if you substitute that into the formula, we have S2 to be 0 plus S1 to be P. You have 0 plus P over 2, comma. Our y2 is a q, which is this, plus our y1 is 0, you have q plus 0 over 2 also. So 0 plus p will give us a p over 2. So we have p over 2. Then q plus 0 give us q also over 2. So 2 cannot go in p, 2 cannot go in q, so you can't divide this. So the midpoint of point E and F is going to be p over 2 comma q over 2 as well. So that means this is the midpoint of point E and point Q. Sorry, point E and point F rather. So another example here, and this is an indirect question. It's an indirect question, just like we have under the distance between 2 points, and this is a jump question also. We are told that if M having the coordinate of 4 comma q is the midpoint of the line joining point L having p comma minus 2 as the coordinate, and point N having q comma p as the coordinate also, we have to find the value of p and q. So which principle are we going to use to solve this? You are going to use midpoint. It didn't say distance between the 2 points, they said the midpoint. So you are going to use the principle of midpoint to find your p and q. In this case, what is the formula for finding the midpoint between 2 points? So in this case, between point L and point N. So formula for finding midpoint of a Ln will be s2 plus s1 over 2 comma y2 plus 1 y1 over 2. Don't forget that they are in brackets, so because you're going to get another coordinate, so you are supposed to use in brackets. Then from here we are given that this value here, this point M, which is having this coordinate, is the midpoint of this L and N. So that means the midpoint of Ln is M. So that should give us we have a 4 comma q here. So you have 4 comma q is equals to our s2 between this one and this one is s2 is q, and our s1 is p. So we have a q plus p over 2 comma our y2 is a p, our y1 is minus 2. So we have a p plus open bracket minus 2 over 2. If you simplify this further, plus times minus will give us a minus here. So we'll be having p minus 2 over 2 here. So what can we deduce from there? We can deduce that we are having a coordinate here, because we cannot have p plus q together. So you're having p minus 2 also, we cannot subtract them. So what do? This a coordinate equals to a coordinate. So that means this 4 will be equal to this one here, which is representing x. So 4 is x here. This one is also x, so they will be equal. Then p is y, and this one also y here, they will be equal as well. So that will help us to get equation. So we have 4 equals to p plus q over 2. So which we can simplify further to get an equation there. If you cross multiply here, you'll be having p plus q to be equal to 4 times 2 give us 8, equation 1. Then also here, p will be equal to this as well. You'll be having I don't know, I made mistake here. This is sorry, this is p, not q. So change this one. There's an error here. You're having p here. So I wrote here q. Sorry for that. So change this one to 4 comma p. So that means you have p to be equal to what you're having here. So you have p equals to p plus and minus will give us a minus. So we have p minus 2 over 2. From then also you can cross multiply. You'll be having p minus 2 equals to q p times 2 give us a 2p. Then collect like times, you'll be having that the p, then this comes here, you have minus 2q equals to 2, which is equation 2. So we can now solve equation 1 and equation 2 simultaneously to find p and q. And how can we do that? We can subtract equation 1 from, we can subtract equation 2 from equation 1. So solve equation 1 and equation 2 simultaneously. So equation 1 minus equation 2, that is subtract equation 2 from equation 1. So we have p minus p, that gives us 0. So we'll be having q minus minus 2q. Q minus minus 2q, that should give us a p and q plus 2q, that give us a 3q. Then you have 8 minus 2, that gives us 6. Divide both sides by 3. Q will be equals to 2. Then you can now substitute this into equation 1 or equation 2 to find our Q. Then from there, substitute Q equals to 2 into equation 1 to find our P. Then from there, equation 1 says the P plus Q equals to 8. Then our Q is 2, so we have P plus 2 equals to 8. Collect like times P will be equals to 8 minus 2. P will be equals to 6. So in this case, the value of P is 6 and the value of Q is 2. So which we have used the principle of midpoint to find the value of P and Q in this question. So also, if you understand how to use the formula for finding the midpoint of 2 points, you can apply this, you can work on these two equations we are having on the these examples, evaluation question we are having here. They're just 3. Lay your hands on them and drop your answer in the comment section of this video so that it can help you confirm whether you are right or wrong. So we have talked about the meaning of coordinates. We have talked about how we can find the distance between 2 points by using the formula, which is the change in square root of change in x squared plus y squared, plus change in y squared rather. Then also we have talked about how to find the midpoint between 2 points using the formula. The next topic we are going to be discussing is the gradient of straight lines. Gradient of straight lines is the next topic after we have discussed distance between 2 points and the midpoint of 2 points. The next topic we are going to be talking about under coordinate geometry is the gradient of straight lines. Before we talk about the gradient of straight lines, I want to show you different forms of straight line that we have and the nature of a gradient that each of the lines has. So I'll be showing you different form of straight lines. The first one is this horizontal line we are having on the screen right now, and this horizontal line have a gradient to be 0. That is the gradient of this straight line, which is horizontal line, is equal to 0. Then we also have a vertical line, and the gradient of this vertical line, which is also a straight line, is equal to 0. And also we could have a straight line that is bent upward to the right, and this straight line will give us a positive gradient. And we could also have a straight line that bent upward to the left, so this straight line also will give us a negative gradient. So since we are finding gradient of straight lines, it is expedient that we know the different forms of straight line that we have and the nature of their gradient. So this will give us a zero gradient, positive gradient, and this one will give us a negative gradient. So that when we draw the graph of the straight lines and we try to find the gradient of the straight lines, before we even try to find, we should know the nature of the gradient we are going to get, whether it is positive or negative, or we have no gradient at all. Having known this base, let's see the ways of finding gradient of straight lines before we now discuss the meaning of gradient. So there are ways of finding gradient of straight line, and the first way is we can find gradient of straight line from the graph. So when you draw the graph of a straight line, and from the graph we can equally find the gradient from the graph, and we know that it is a linear equation that will give us a straight line graph. So when we draw the graph of a linear equation and it gives us a straight line from the graph, we can equally find the gradient. And also, without drawing the graph out, also we can still find the gradient of the straight line. When we are given the 2 coordinates that the straight line passes through, we can use those 2 coordinates to find the gradient of the straight line also. That is to say, we can still find gradient of a straight line given 2 points, that is given the coordinate of 2 points that the straight line passes through. And also we can find gradient of a straight line from the equation that represents the straight line. So we can still find equation of straight line given the equation that represents the straight lines. So these are the three ways in which you can find gradient of straight lines. Although this the scope of this video is not for us to draw a graph and find gradients from it, no. Although we are going to talk about it briefly, but the scope of this video is to talk about how we can find gradient of a straight line given 2 points that the straight line passes through, and how we can also find gradient from the equation that represent the straight lines. So let's dive into gradient proper. Now, gradient, another name for gradient is called slope. Another name for gradient is slope. And so in mathematics we literally call it gradient, but in physics they call it slope. So but I want you to know that the gradient and slope are the same thing. So let's see how we can find the gradient of a straight line. Now let's assume that this is a graph. We have a y-axis and we have x-axis. And if I draw, assuming I draw a graph now, and I have this straight line drawn. Now I believe now you should know the nature of the gradient you are going to get for this straight line. Is it going to be positive gradient or negative gradient or zero gradient? Of course, it's going to be a positive gradient. This straight line will give us a positive gradient. Now, if you have to find the gradient of this straight line, what do we do? Of course, what you will do is to first of all form a triangle with this straight line. Assuming you draw a graph of a straight line and you now want to find the gradient of that straight line, you need to form a right angle triangle with this straight line. And if I should do same thing, okay, let's assume that this straight line passes through point A, having coordinate of x1 and y1, and it also pass through point B having s2 and y2. So if I want to find the gradient of this straight line, I need to form a right angle triangle with this straight line. So if I should draw that right angle, I draw a straight line from here and I join it to this one as well, which will give us a right angle triangle. So of course we know that if this point is a point A and having this coordinate, so that means the value of A on the x-axis is going to be x1, the value of A on the y-axis is going to be y1. Likewise, the value of point B on the x-axis is going to be s2, value of point B on the y-axis is going to be y2. So what does gradient means, or slope, what does it mean? To find the gradient of the straight line, having drawn make a right angle triangle with the straight line, we need to find the change in y-axis. We need to find the change in this y-axis, which is same thing as from here to here, from y2 to y1, and we need to find the change in x-axis, which is from s2 to x1. So gradient is talking about the ratio, the gradient of this straight line. Don't forget that we are looking for gradient of a straight line. The gradient of this straight line is talking about the the ratio of the change in y-axis to change in x-axis. That is the meaning of gradient. The ratio of the change in y-axis to change in x-axis. We know that ratio means that division. So of course this side is going to be, you have change in y here, we have change in which same thing as y2 minus y1, because the distance from this line to this line is this minus this. So assuming this y2 is 10, this one is 5, so to get distance from here to here, that will be 10 minus 5. So that means the change in y, which is from here to here, is same thing as our y2 minus y1. Likewise, our change in x is going to be our s2 minus x1 as well. So therefore, gradient and the symbol or the variable that represents gradient is m. The variable that represents gradient is m. So gradient is equals to change in y over change in x. Change in y over change in x, that is gradient. And we know that gradient is same thing as m, which is equal to our change in y is y2 minus y1 over s2 minus x1. So this is how to find gradient of a straight line. When we draw the graph of the straight line, form a triangle with the straight line, then calculate the change in y over change in x. So Also, if we do not draw the graph, but rather we are given the 2 points, that is, we are given the coordinate of 2 points that the straight line passes through, we can still find the gradient of that straight line. I will come again. If we are now asked to draw the graph of the straight line, so that means you cannot find the gradient from the graph, but rather we are given 2 coordinates that the straight line passes through, we can still find the gradient of the straight line. And that is what this video is tend to talked about. So if I'm giving the gradient of A, I'm giving the coordinate of A, I'm giving the coordinate of B, and we are told that that straight line passes through those 2 points, we can still find the gradient of the straight line using this formula, y2 minus y1 over s2 minus x1. Because from the first coordinate we get our s1 and y1, from the second coordinate we get our y2 and our s2 and s1. So we can still use this formula to find the gradient of the straight line. Do we understand that? And also not only gradient we can find, we can also be able to find the angle of the slope. We can also find the angle of the gradient or angle of slope. So if I mark the angle that is formed here in this right angle triangle, this angle here, which you can call theta, have relationship with this side, which is changing y, and this side, which is changing x. That is opposite over adjacent, that will be tan. So the angle of slope, which is the angle of this gradient, is equals to the gradient itself, which is changing y over changing x. So the angle of slope is equals to, we have tan theta, which is the theta is the angle of the slope, equals to changing y over changing x. So that means tan theta will be equals to the gradient itself, which is y2 minus y1 over s2 minus x1. So we can be asked to find the angle of slope also, that will be tan theta equals to the gradient you found. Then you can now find theta by using the tan inverse of the value of the slope. So to find gradient of a straight line, so a student needs to remember that the formula for finding gradient is y2 minus y1 over s2 minus s1, which is the same thing as changing y over changing x. So let's use this to solve some questions. Now we have to find the gradient of the line joining the points with this coordinate and this coordinate. So we have to find the gradient of the straight line that passes through this point and this point. And we know that from this first point, this will be our s1, our y1, s2, and our y2. So to find the gradient, we know that the formula, you need to remember the formula, that will be y2 minus y1 over s2 minus x1. Then if you substitute this value into this formula, then what do we have? Our y2 is 11, so we have 11 minus y1 is minus 4, in bracket minus 4 over our s2 is 3, and our s1 is minus 2. You have 3 minus open bracket minus 2. So minus times minus will give us plus. So we'll be having 11 plus 4. Then minus times minus here will also give us plus. You have 3 plus 2. So that should give us 15 over 5. So the gradient will be equal to 3. So the gradient of the straight line that passes through this point and this point will give us 3. Let's see another example. We have to find the gradient of the line joining this point and this point, and also we have to find the angle of slope of the line. So of course, to find the gradient, we know that the gradient is y2 minus y1 over s2 minus x1. Our y2 is 10, and our y1 is 2. Our s2 is 7. Our s1 is 3. So if you substitute that into this formula, we have that we have to be 10 minus 2 over 7 minus 3. If you simplify that, will give us 8 over 4, and that will give us gradient to be 2. So don't forget that the variable to represent gradient is m. Don't forget that. So anywhere you see m in the coordinate geometry, that represents gradients. So the gradient is 2, and we have to find the angle of slope also. I know that to find the angle of slope, that will be tan theta equals to the gradient itself. So from there, tan theta will be equal to 2 because the gradient is 2. So from there you can find the tan inverse of 2. tan inverse of 2 will give us 63.4 degrees. So the angle of slope is 63.4 degrees. Also, let's see example 3. Example 3 is an indirect question, and this question is from JAMB. We are told that what is the value of P if the gradient of the line joining this point and this point is 2/3. So we have to use gradient to the gradient of the straight line that passes through this coordinate and this coordinate, and the gradient is giving us 2/3. You have to use that gradient to find a P. So if you do that, also gradient is changing y over changing x, and from this point, these 2 points that the line passes through, we know our y2 to be 4, our y1 to be p, our s2 is p, our s1 is -1, and we will be given the gradient, the value of the gradient of that straight line. The gradient is 2/3, so 2/3 we will place this m here, so we have 2/3 equals to our y2 is 4, we have 4, then minus our y1 is p, so we have 4 minus p over our s2 is p, also we have p minus our s1 is -1. So if you simplify that further, we have that minus times minus will give us plus here, so we'll be having 2/3 equals to 4 minus p over p plus 1. From there we can cross multiply, so 2 will multiply p plus 1, 3 will multiply 4 minus p, and that should give us a 2 into bracket p plus 1 equals to 3 into 4 minus p. Then we can open the brackets from here. We have 2 multiply p, that gives us a 2p, 2 multiply 1 plus 2 equals to 3 times 4 give us 12, then 3 times minus p give us minus 3p. Then from there we can collect like times. We have 2p, then 3p minus 3p come here, become plus 3p equals to 12, then 2 comes here minus 2. 2p plus 3p give us a 5p, 12 minus 2 is 10. Can divide both sides by 5, that gives us a p to be 2. So we can see that we have used a gradient that we have known to find the missing value in the coordinate, which is p, and p give us 2. So this is an indirect question that you could resolve using the gradient. So if you understand how to find the gradient of a straight line that you have just explained now, you can just try out these 3 questions on gradients, and let's see how you can work on this. If you are able to do it, please leave your answer in the comment section of this video, so that we can help you check whether you are right or wrong. Now the next thing we are going to be talking about is how we can find gradient of a straight line from the equation of the straight line. So we have talked about how we can find the gradient of straight line given that the coordinates that a straight line passes through. That's what we just discussed. Now I want to see how we can find gradient from the equation of straight line. So we want to find gradient from the equation of the straight line. So the general equation of straight line is we have a general equation of straight line, and that is y is equals to ms plus c. Because you must remember as a student that the only equation that gives us a straight line graph is a linear equation. The only equation that gives us a straight line graph is a linear equation, whether a linear equation of 1 variable or 2 variable and so on. But the only equation that can give us a straight line graph is a linear equation. So in this case, if I'm given a linear equation, from the linear equation I should be able to find gradient of the straight line. Don't forget that that linear equation is representing a straight line. Now, to be able to do that, you need to remember always the general equation of a straight line, that is y is equals to mx plus c. This is a general equation of a straight line, and y and x are the axes of the graph. This is y-axis, this is x-axis. M represent gradients, and c represent the y-intercept, where the straight line cut the y-axis. That is what c represents. So in this linear, this is the template, or this is a general equation of a linear equation. So from here now, this one is telling us that our m is gradient and c is y-intercept. So if I'm given a linear equation to find gradient from it, all I need to do is to make sure that that equation given to me is expressed like this. Then when it is expressed like this, then the coefficient of x will be my gradient in that case. So if the equation is not expressed like this when it is given to you, so the first thing to do is to make sure that you make sure that it is expressed like this. Then from there you can find the gradients. So I'm going to be solving some question now, given the equation of straight line to find gradient from it. The first thing to do is to make sure that you make sure that the equation look like this by making y subject of the formula first, and the equation of s will now be the gradient. Now let's start with the first question we are having here. Look at the question you're having. You have to find the gradient and the y-intercept of the straight line. Y is equal to 4s plus 5. This is a linear equation. Y is equal to 4s plus 5. So from this equation, we have to find the gradient of this straight line. Don't forget that this linear equation is representing a straight line. Don't forget that. So from this linear equation, we have to get the gradient of the straight line. And from the general equation of the straight line that I showed you before, y is equal to ms plus c. So we have to express this equation like this one. But you can see that this equation is already expressed like this because y is already subject to the formula here. So there's no problem. So you can easily get the gradient. So this equation given to us to find gradient is already like a general equation of straight line. So that means the gradient is going to be the coefficient of x, because don't forget that m represents gradient. So m here is equal to what? 4 in this case. So our gradient is going to be 4. Then y-intercept, which is c, is going to be what? 5. So y-intercept is going to be 5 as well. So the gradient of this straight line is 4, and y-intercept is what? 5. Do we understand that? So that's how to get a gradient from the equation of straight line. But there's another thing they can ask you to do, especially for further mathematics students. They can ask you also to sketch the graph that represents this straight line. So you can be asked to sketch, not to draw. Drawing is different from sketching. If you want to draw a graph, you need a graph book to draw. But if you have to sketch, you can just sketch with your pencil. So if you have to sketch this equation, this straight line that represents this equation, all you need to do is to draw your x-axis and your y-axis and x-axis. Then how would the straight line go? Will it be a vertical line or horizontal line, or a bent line like this, or like this one? How would the straight line go? So the nature of the gradient that you get, the gradient that you got will tell you how the straight line will go. But you can see that the straight line is a positive straight line. Sorry, the gradient is a positive gradient rather. So that means the straight line should go like this. Remember at the beginning of when I wanted to start explaining gradient, I gave you different form of straight line, and I told you the gradient that they are to get, that they represent. So this is a positive gradient, so that means the straight line will go like this. But where will it pass on y-axis? That is what y-intercept is talking about. It's going to pass through 5, and 5 is a positive number. So you go to the positive on the y-axis. I'm going to have 5 around somewhere here. So if 5 is here, so that means that straight line is going to pass through 5 here. So if I draw the straight line, it's going to go like this. Are we there? So the reason why this line is going like this is because of this gradient, because it is 4. It is positive gradient, and it is passing on the y-axis 5. So that's why it's going like this. Then what else do I do? I need to form my right angle with it. So I will draw my right angle with this straight line. Are we there? Then I need to put don't forget that when we are talking about gradient is the ratio of the change in y over change in x. So we need to change this gradient, which is 4, to a fraction. So the gradient is always in fraction, change in y over change in x. So change this 4 to a fraction, that will be 4 over 1. 4 over 1 same thing as 4. So that means on the y-axis, change in y will have 4 here. on changing y, we have 4 there, and on changing x, which is this side, we'll be having what, 1 there. So this is the diagram that represents this equation if you're asked to sketch it. So let's see other question that you can solve to understand it better. Example 2, we have to find the gradient and the y-intercept of the straight line 3y minus 2x plus 5 equals to 0. We can see that this equation given to us is a linear equation, but it is not yet expressed like the general equation of straight line. So you are given 3y minus 2x plus 5y. All you need to do is first of all make this equation to be like general equation of straight line. That means we need to make y subject of the formula. And how do we do that? So you need to take 2s to this side, take 5 to this side. So you'll be having 3y is equal to 2s minus 5. Then we need to divide both sides by 3. So if I divide both sides by 3, I will have 2s minus 5 over 3. Then we can split this fraction. So if you split it, that will be 2. We'll be having y is equal to 2 over 3x minus 5 over 3. So we have splitted this fraction. So then you can now see that this equation we now get is now like the general equation of a straight line, because we're having y is equal to ms plus c. So we have already made y so the formula. So from here now you can now get our gradient, which is the coefficient of x. So gradient, which is m, is equal to 2 over 3. Then the y-intercept will be minus 5 over 3. The y-intercept is what? Minus 5 over 3. So we have been able to find the gradient of this straight line to be 2 over 3, and the y-intercept is minus 5 over 3. So if you have to scale this also, draw your axis. And having drawn your axis, how would this straight line go? Will it go like this or like this? That depends on the nature of your gradient. The gradient we have here is a positive gradient, so that means it will still go like this. And on the y-axis, where will it pass? It's going to pass minus 5 over 3. So it's going to pass the negative side of y. So we'll be having minus 5 over 3 around here. So that means the straight line will pass somewhere here. So we'll be having it like this. Then having drawn that, you need to form a right angle triangle with this. So if you form a right angle triangle with this now, then on the change in y, what am I going to put in change in y? That will be, I'm going to put 2. So I'll be having 2 on the change in y. And on the change in s, what am I going to put here? I'm going to having what? 3. So this is the diagram that represents this equation of straight line. So don't forget, our aim is to find gradient and y-intercept, but I'm just showing you this in case they ask you to do it. So the gradient is 2 over 3 and y-intercept is minus 5 over 3. Let's see more questions that could challenge us. Here we have to find the gradient and the y-intercept of the straight line minus 4x minus 3y plus 2 is equal to 0. So of course you can see that this equation given to us is not yet expressed like that general equation of a straight line. So the first thing to use to express it first by making y so the formula. So you can collect like times. If you collect like times, minus 4x will come here, 2 will also come here. So we have minus 3y equals to 4x plus 2. Then you can multiply through by minus so that it will take care of this minus here. If you multiply this minus 3y by minus, that gives us 3y. Multiply this one by minus, that gives us minus 4x. Multiply minus 2 by minus, that gives us plus 2. Now we can now divide both sides by 3 now. If you divide both sides by 3, so if you divide this one by 3, you have minus 4 over 3x. Divide this one by 3 as well, you have plus 2 over 3 as well. Now we can now see that this has been expressed like that general equation of a straight line, which is y is equal to ms plus c. So now you can see the coefficient of x here is a minus 4 over 3. So that means the gradient, which is going to be minus 4 over 3, and the y-intercept is going to be 2 over 3. So don't forget that we are trying to know how to find gradient of a straight line from the equation of the straight line. And that's what we are working on right now. I've been talked about how we can find gradient given the two coordinate that the straight line passes through. We have talked about that already. So we are seeing other way of finding equation of other way of finding gradient of the straight line from the equation itself, and we have been demonstrating that with different examples. And we have seen the gradient to be minus 4 over 3 and the y-intercept is 2 over 3. Let's try to scale the graph also in case you have to do that also. draw your axis, and after drawing the axis, I want to ask you, how would the line go? How would the line go? What do you think? How would the line go? Will it go like this, or it will go like this? How would it go? It's going to go like this because our gradient is a negative gradient. It's going to go like this now, and then it's going to pass through 2/3 on the y-axis. So it's going to pass through around somewhere here, 2/3. So let's assume that this is 2/3. Then our straight line will pass through that point, 2/3. So it's going to go like this. Are we there? So why is it like this? Because our gradient is a negative gradient. So this one give us a negative gradient, and it is passing the 2/3 on the y-axis. Then I'll form a right angle with this. After forming a right angle with this, then what will be the value of my change in y? That should be -4. And then what's the value of my change in x here? This down from here to here. What will be the value of that? That will be 3. So I have 3 here also. So this is the graph that represents this equation. I haven't gotten the gradient and y-intercept. Now let's see last question on this last example. We are given you are to find the gradient and y-intercept of the straight line x/5 equals to y over 4 plus 2. So this is also a linear equation as well, and we have to find the gradient and the y-intercept of this. It's very simple as well. We have x/5 equals to y over 4 plus 2. Now the first thing to do is to find a way of removing these denominators 5 and 4. And how can we remove that? Is by finding the LCM of 5 and 4. Then we now multiply it through by the LCM. So what is the LCM of 5 and 4? That should be 20. So we now multiply each of these by 20 so that it can help us to clear the denominators. So multiply through by the LCM of 5 and 4. So if I multiply this by 20, I'll have 20 times x/5 equals to 20 times y over 4 plus 20 times 2. So we have been able to multiply through by the LCM. So from there, 5 will go in 20, that will be 4. 4 times x will give us 4x equals to 4 in 20 will give us 5. 5 times y will give us 5y plus 2 times 20 times 2 is 40. So you can see that we are now back to a simple linear equation now. And still more, we need to make y solve the formula before we can find the gradient and the y-intercept. So because we need to make it look like the general equation of a straight line. So what we do, we need to collect like terms. I can take this 40 to this side, so I'll be having 5y is equals to 4x minus 40. That I can now divide both sides by 5. So we'll be having 5 and y is equals to 4 over 5x minus 40 divided by 5 will give us 8. So from there now, I want you to can you tell me the gradient of this straight line? What will be the gradient of the straight line now? Our m is going to be 4 over 5. And the y-intercept is going to be what? -8. So I'm not going to sketch the graph for this one. You can try to demonstrate that on your own. Sketch the graph and draw the line and put the gradient also on the graph and test your ability on that. But here we are only asked to find gradient and y-intercept, which is 4 over 5 and -8. So if you understand what you have done so far in the finding gradient and y-intercept from the equation of straight line, so you can try these 3 equations by finding the gradient and y-intercept of each of them. And if you like, you can also sketch the diagram to help you understand how to go about it. And then when you are done, you can drop the solution in the comment section of this video so as to help you evaluate it and get back to you on that. Now, having talked about how we can find gradient from how we can find gradient of a straight line, the next topic is to talk about equation of straight lines. Equation of straight line. We want to find equation of straight line. Now, of course, I've already given you some explanation on equation of straight line. The equation of straight line is a linear equation. equation of straight line is a linear equation. You know that before. So equation of straight line is a linear equation, and the linear equation could be of one variable. Don't forget that. Example is s is equal to 5. This is a linear equation which can be written as s minus 5 is equal to 0. So this is a linear equation of one variable. The variable here is x. I could also have a y is equal to minus 4. This is another linear equation of one variable. Because this one can also be written as a y plus 4 equals to 0. So this is a linear equation. This one will give us a vertical line graph, and you draw the graph of this one. This one is going to give us an horizontal line graph, which is also a straight line. Then also we could also have a linear equation of two variables. This one will give us a slant line like this or like this. So a linear equation of two variables. An example is the general equation of linear equation y is equal to ms plus c. So this is a linear equation of two variables. So our aim is to be able to find equation of straight lines. How can we get equation of straight line? That is equation that will look like this. How can we find it? Now there are ways of finding equation of straight lines, and let's first of all know those ways before we now start finding those equations one after the other. The first way of finding equation of straight line is giving the gradient and the y-intercept of the straight line. So when I'm giving the gradient and the y-intercept of the straight line, we can use that to find equation of that straight line. So that's one way of doing it. You can also find the equation of a straight line when we are giving the gradient and a coordinate of the coordinate of a point that the straight line passes through. So it's not only when you are giving gradient and y-intercept of the straight line that you can find the equation. No, we can also find the equation of a straight line giving the gradient 1, and we are also giving the coordinate of a point or giving the coordinate of one point that the straight line passes through. We can still find the equation of the straight line, and also we can find the equation of a straight line given the coordinate of 2 points that the straight line passes through. So these are the three ways in which we can find the equation of straight line, and we are going to be demonstrating them one after the other with questions. Are we there? So let's jump into solving let's jump into finding equation of straight line in these three ways. Now the first question we have there, example, it says that we have to determine equation of straight line whose gradient is 3 and y-intercept is 2. Don't forget, in our previous topic, we found gradient and y-intercept given the equation. Don't forget that. Now, we are now looking for the equation given the gradient and y-intercept. So, now we want to find the equation of straight line given the gradient and the y-intercept. So, we have to determine equation of straight line now, whose gradient is 3 and y-intercept is 2. How do we do that? It's very simple. Don't forget that the equation you are looking for, which is equation of straight line, is a linear equation. So it's going to take the format of the general equation of straight line, which is y is equal to ms plus c. We know that m represents gradient and c represents what? Y-intercept. You have been given the gradient and you have been given y-intercept, which is 2. So substitute that into this equation. Our gradient is 3, our c is 2, which is y-intercept. Put that into this equation. You have that y is equal to 3s plus 2. So this is the equation of the straight line whose gradient is 3 and intercept is what? 2. So we have been able to get the equation, which is y is equal to 3s plus 2. As simple as that. As simple as that. So the equation of the straight line whose gradient is 3 and intercept is 2 is y is equal to 3s plus 2. Do you understand that? Let's see more example. We have to find the equation of the straight line whose gradient is minus 7 over 2 and y-intercept is what? Minus 2. So, of course, you remember the general equation of straight line, which is y is equal to ms plus c. So, our gradient here, m is equal to minus 7 over 2 and y-intercept is minus 2. So, if you put that into this, you'll be having y is equal to, our m is minus 7 over 2 x plus c is minus 2. You have open bracket minus 2. We can simplify this one further. Minus times plus will give us a minus. So we'll be having y is equal to minus 7 over 2s minus 2. Then Of course, you can leave your answer like this is an equation you are looking for, or you can still simplify it better in case it's an objective question and you check your option and the option is not in this format. That means you can still do something. We can then multiply through by the LCM of the denominator. So the denominator here is 2, so we can multiply through by 2. So if you multiply this y by 2, that will give us 2y. If I multiply minus 7 over 2 by 2, the 2 we cancel the 2 here, so you have minus 7x. If I multiply this one by 2, that gives us minus 4. So that means the equation is 2y equals to minus 7x minus 4. So this is the equation the equation of the straight line we get when the gradient is this and the y-intercept is this as well. So let's see another way of finding equation of straight line. In this case, we are given that we have to find equation of straight line of slope 2 if it passes through the point 3, minus 2. Look at this question and compare with the one we just solved now. We are given the gradient to be 2, and we are told that the straight line passes through this coordinate 3, minus 2. So in this case, we are given the gradient, but we are not given the y-intercept. Rather, we are given a coordinate that the straight line passes through. Yet, they want to also find the equation of the straight line because it is very, very much possible. So all you need to do is to remember the general equation of straight line, which is y is equals to ms plus c. And then in this case, our m is what? 2. And we are told that it passes through 3, minus 2. So remember the general equation, which is y equals to ms plus c. M is what? 2. If you put that here, you have a y is equals to 2s plus c. The only thing that we need to find now is our c, which is the y-intercept. And that's the reason why you are given this point that it passes through. So at 3, minus 2, that means 3 represents our x, and minus 2 is what? Y. So put 3 here, put minus 2 here, you will be able to find what? C. So that means at that point in time, the equation becomes minus 2 equals to 2 times 3 plus c, which if you simplify, you have minus 2 is equals to 6 plus c. Make c solve a formula by taking 6 here. You have 6 is equals to minus 2 minus 6. Then c will be equals to minus 8. So that means the y-intercept is what? Minus 8. So return that here. So that will be equals to y is equals to 2x minus 8, which is the equation of the straight line that we are looking for. So the equation is y equals to 2x minus what? Minus 8. We understand this as well. Let's see more question on that also. Example 4. You have to find the equation of the straight line of gradient minus 1 over 3 if it passes through the point 1, 1. So in this case also, we are not given the y-intercept. We are given the gradient, which is minus 1 over 3. We are given the coordinate of a point that it passes through. So we can use that to find the y-intercept. So in this case, gradient is 1 over 3. And then we are told that it passes through 1, 1. Then also, you need to remember that the general equation of straight line is y equals to ms plus c. If you put the gradient here, so you'll be having y is equals to minus 1 over 3 x plus c. So the only thing that is left for us to find is the value of c, which is the y-intercept. And you can find that using the point that the line passes through, which is 1, 1. At this point, x is 1 and y is 1 also. So if you put that into this equation, you'll be having 1, which is our y is equals to minus 1 over 3 times x, which is 1 also, times 1 plus c. If you simplify this, that should give us a 1 is equals to minus 1 over 3 plus c. For like times, take minus 1 over 3 to this side. You'll be having c is equals to 1 plus 1 over 3. Can now find LCM here to find the LCM here to bring this together. So the LCM of you can make this 1 over 1. 1 and 3 is LCM of 1 and 3 is 3. So 1 in 3 give us 3. 3 times 1 give us 4. Then 3 in 3 is 1. 1 times 1 give us 1. So that will give us 4 plus 1. That give us 5 over 3. Sorry. 4 over 3 rather. I made a mistake. 1 in 3 is 3. 3 times 1 is 3. So Then 3 in 3 is 1, 1 times 1 is 1, so 3 plus 1 give us 4 over 3. So that means the y-intercept is 4 over 3. So if you return that into this where c is here right now, you'll be having y is equals to minus 1 over 3x plus 4 over 3. So this is the equation of the straight line that we are looking for. But we can decide to clear the denominator here by multiplying through by 3. So if I multiply this one by 3, I have 3y. If I multiply this one by 3, 3 will cancel 3, I have minus x left. If I multiply this one by 3, 3 will cancel 3, you have 4 left. So this is the equation of the straight line that we are looking for. So example 5 also. Now we have to find the equation of the straight line which passes through this point and this point. So in this case now we are looking for equation of straight line giving two coordinates, or giving the coordinate of 2 points that the straight line passes through. Now we are not giving gradient and we are not giving y-intercept, but rather we are giving coordinate of 2 points that the straight line passes through. How can we find the gradient of that straight line? It is still very much possible using the general equation of straight line. So although there's another formula you can use for that to find this, but nevertheless I prefer this method, and that's why I'm showing you this method. Now there's a what we do is that of course we know that the straight line passes through this point and this point, so we can find the gradient of the straight line using these 2 points. And don't forget that we have talked about how to find gradient of straight line given 2 points that the line passes through. So we can find the gradient of the straight line, which is m. So gradient of straight line is equals to gradient is equals to change in y over change in x. So that means our gradient is going to be, our y2 is 2, our y1 is minus 3. So we have 2 minus open bracket minus 3 over our s2 is minus 4, and our s1 is 2. So we have minus 4 minus 2. Minus times minus give us plus. So we have gradient will be equals to 2 plus 3 over minus 6. And then that means the gradient will be equals to minus 5 over 6. So the gradient of the straight line is going to be minus 5 over 6. So now that we know the gradient of the straight line, remember the general equation of straight line, which is y equals to ms plus c. Then put the gradient here. We'll be having y is equals to minus 5 over 6x plus c. The only thing that is left for us to find is the y-intercept, which is c. Then you can find that by using any of these 2 points, whether I use this one or use this one. So you can use at any of these 2 points, you can find your c. So if I use this, another student use this one, we are meant to get the same answer. So don't use both of them. Just pick one point that the line passes through and use it to find your y-intercept. So at 2 comma minus 3, that means our x is 2, our y is minus 3. So put that into this equation. We'll be having minus 3 equals to minus 5 over 6 times x, which is 2, times 2 plus c. 2 here 1, 2 in 6 is 3. We'll be having minus 5 over 3 here. So we're having minus 3 equals to minus 5 over 3 plus c. Collect like times here by taking this to this side. You have a c is equals to minus 3 plus 5 over 3. Then you can now find the LCM here to bring this together. If you do that quite very well, you know that the LCM is of 1 and 3 is 3. 1 and 3 is 3. Then 3 times minus 3 is minus 9. Plus 3 in 3 is 1. 1 times 5 is 5. So minus 9 plus 5 will give us minus 4 over 3. So that means the y-intercept is minus 4 over 3. If you take this one now and return it back into this equation here to replace c, you will be having y is equals to minus 5 over 6x, then minus 4 over 3. So this is the equation we are looking for of the straight line, but we can also clear the denominator by multiplying through by the LCM of 6 and 3. So the LCM of 6 and 3 is 6. So you can multiply this by 6. That gives us a 6y equals to multiply this one by 6. That gives us minus 5x. Multiply this one by 6. That gives us minus 8, because 3 in 6 is 2. Then 2 times 4 is give us 8. So that means this one will give us, this is the equation of the straight line that passes through this point and this point. Now, question number example 6, we have to find the equation of the straight line which passes through the point 1 comma minus 1 and 2 comma minus 3. So C is very similar to what we just solved. We are so looking for equation of straight line given the 2 points that the straight line passes through. The first thing to do is to find the gradient of the straight line using the formula for finding gradient of straight line, which is y2 minus y1 over s2 minus x1. So our y2 is minus 3, y1 is minus 1, our s2 is 2, our s1 is 1. If we substitute that into this equation, we have m is equals to minus 3 minus open bracket minus 1 over 2 minus 1. If we simplify this further, we have m is equals to minus 3 plus 1 over 1. So minus 3 plus 1 gives us minus 2 over 1. That gives us the gradient to be minus 2. And remember the general equation of straight line, y is equal to ms plus c. Put your gradient here. So you'll be having y is equal to minus 2s plus c. So all you need to find is the y-intercept now, which is c. Excuse me. Then you can find that whether by using this point or this point. So let's use this second point now in this case. So at 2 comma minus 3, that means our y is minus 3, so that will replace this one here. Our s is 2, that will replace this one here, so that you can find c. So if you substitute that into this equation here, we have minus 3 equals to minus 2 times 2 plus c. And that will give us minus 3 equals to minus 4 plus c. Then from there, if you collect like times here, so c will be equals to minus 3 plus 4. Then c will be equals to 1. So that means the y-intercept is 1. Return back into this place here. You have a y. Sorry for that. This is y equals to not y equals to minus 2s plus 1. Y is equals to minus 2s plus 1. That is the equation. That's the typographical error. Y is equals to minus 2s plus 1. That's the equation of the straight line. Now, if you understand how to find the equation of straight line in using the 3 ways I've explained so far, then please lay your hands on these 3 questions and lay your hands on these 3 questions. Lay your hands on these 3 questions and try to find the equation of each of the questions you have here, and drop your answer in the comment section of this video, and I will respond to them one after the other. Now, the next thing we are going to be talking about is parallelism and perpendicularity of straight lines. Parallelism and perpendicularity of straight lines. Those are the next that's the next topic we are to discuss. Now, parallelism is from the word parallel, and perpendicularity is from the word perpendicular. Now, under straight line geometry, under plane geometry, or that's parallel line, we know when 2 lines are parallel, we know that 2 parallel lines do not meet. So 2 parallel lines do not meet. So and we know that when 2 lines are perpendicular, also 2 lines are perpendicular when they meet at angle 90 degrees. So now that is for straight line geometry or plane geometry. Now when it comes to coordinate geometry, now when do we say that 2 lines are parallel and when do we say that 2 lines are perpendicular? Before we can say that 2 straight lines are parallel or perpendicular, they must satisfy some condition. So there's condition for parallelism and there's condition for perpendicularity. Before we can say that 2 lines are parallel, the condition is that the gradient of the 2 lines must be equal or must be the same thing. So for 2 lines to be parallel in a coordinate geometry, that means they must have equal gradients. So m1 will be equal to m2, where m1 and m2 represent the gradient of the 2 straight lines that are parallel. So where m1 and m2 are the gradient of the 2 lines that are parallel. And also for perpendicularity, before we can say that 2 lines are perpendicular in coordinate geometry, that means the product of their gradients must be equal to -1. That is m1 and m1 times m2 must be equals to minus 1. m1 times m2 must be equals to minus 1, where m1 and m2 are the gradient of the two lines. So a student that wants to understand this must remember that the condition for parallelism is m1 equals to m2. That is, the gradient of these two lines must be equal before we can say they are parallel. And for perpendicularity also, the gradient of the two, the product of the two, the product of the gradient of the two lines must be equal to minus 1. So you must bear these two conditions in mind if truly you want to be able to solve questions on parallelism and perpendicularity in coordinate geometry. Now let's see what they can ask us to do with these two conditions. Now with the first question, first example here, we have to prove that line AB is parallel to line PQ, given that we are given the coordinate of A, coordinate of B, coordinate of P, and Q. So given these coordinates, you have to prove that line AB is parallel to line PQ. So we know that to find line AB will pass through coordinate A and coordinate B. That will give us line AB, and we know that the line PQ will pass through P and Q also. So you have to show that these two lines are parallel. What do? We need to find the gradient of line AB, need to find the gradient of line PQ. Then if they are equal, that means we have been able to show that they are parallel. And don't forget, let M1 be gradient of line AB, and let M2 be the gradient of line PQ. And don't forget, you have been taught how to find gradient of straight line given the two coordinates that the straight line passes through. So for M1, which is the gradient of line AB, we have a y2 minus y1 over s2 minus s1, which is the formula for finding gradient of straight line. So in this case, for line AB, our y2 is 3, our y1 is 1, our s2 is 4, our s1 is 3. So if you substitute that into this equation, this formula, our m1 will be 3 minus 1 over 4 minus 3. That will give us a 2 over 1. That will give us 2. So the gradient of the line AB using the coordinate of A and B is a 2. Okay, let's find gradient of line PQ as well, which is M2. We have the same formula, y2 minus y1 over s2 minus x1. In this case, our y2 is 8, our y1 is 6, our s2 is 5, our s1 is 4. If you substitute that into this equation, we have 8 minus 6 over 5 minus 4. That will give us a 2 over 1 as well. That will give us a 2. So we can see that M1 is equal to what? M2. So since M1 is equal to M2, therefore you can say that line AB is parallel to line PQ. So these two straight line is the short notation for parallelism or parallel. So you have been able to show that line AB is parallel to line PQ because they have the same gradients. Of course, if you ask you to show that they are not parallel, that means they will not have the same gradient. So that's how to show that they are not parallel. But in this case, they are parallel. Now, example 2, we have to prove that line XY is perpendicular to line PQ, given that we are given the coordinate of X, coordinate of Y, P, and Q. So that means the line XY will pass through coordinate X and Y. Line PQ will also pass through coordinate P and Q. So, and we remember the condition for perpendicularity. That means the product of their gradient must be equal to minus 1. So we need to find the gradient of line SY. We need to find gradient of line PQ as well. So let M1 be the gradient of line SY and let M2 be gradient of line PQ. So to find M1, which is using the formula for finding gradient, so our Y2 will be 2, our Y1 is minus 1, our S2 is 3, our S1 is 5. Substitute that into this equation or this formula. We have 2 minus open bracket minus 1 over 3 minus 5. If minus times minus will give us plus, so we'll be having M1 to be 2 plus 1, that will give us 3 over 3 minus 5 is minus 2, so that will give us minus 3 over 2 for the gradient of line XY. Then M2, which is representing the gradient of line PQ, using the formula also y2 minus y1 over s2 minus x1. So our y2 is 6, our y1 is 4, our s2 is 5, our s1 is 2. If you put that in this formula, what will it become? we'll be having 6 minus 4 over 5 minus 2, and from there it will not, if you simplify further, we'll be having 6 minus 4 is 2 over 5 minus 3 is 3. So 5 minus 2 is 3. Then the gradient of the line PQ is 2 over 3. So you can see that they are not equal. That means they are not parallel. In case you have to show that they are not parallel. You can see that the gradient of this one and this one is not equal. That means they are not parallel. But in this case, they ask also to show that they are perpendicular, not parallel. So what is the condition for perpendicular? M1, M2. So if you put your M1 multiplied by M2 and it give you minus 1, that means they are perpendicular. Our M1 we got is minus 3 over 2 times our M1 is 2 over 3. So if you multiply them out, 3 will cancel 3, 2 will cancel 2. So I left with what? Minus 1. So that means the product of their gradient is equal to minus 1, which is the condition for perpendicularity. So it means that line XY is perpendicular to what? Line what? PQ. And that is how to prove, and that is how to show that. Which I believe you understand that. Alright. Also, we can also be given the equation of the straight lines, or two straight lines rather. Then from and you have to show that they are parallel or they are perpendicular. So like this question now, we have to show that the straight line y is equal to 2x plus 3 is parallel to the line 4y equals to 8x minus 5. So you know that what we need to do is to find the gradient of this straight line, which is what we have done. How we can find gradient from the equation of the straight line, we have done that before. And what we need to do also here, you need to find the gradient of this straight line as well. And if what we get is are equal, then that means they are parallel, because that's the condition for parallelism. The gradient of this first line must be equal to gradient of this second line as well. So let's find the gradient of the first line. Y is equal to y is equal to 2x plus 3. And if you compare this one with the general equation of straight line, you can see that they have already made y sort of the formula here, so we can easily deduce our gradient. So that means our gradient here, which is m1, will be equal to what? Will be 2. So gradient is what? 2 here, which m1 represents the gradient of the first straight line. Let's find the gradient of the second straight line. We have a 4y equals to 8x minus 5. So you can see that this one it has not been expressed like the general equation of straight line. Then we need to do something to this y first. So we need to divide through by 4. If you divide through by 4, we'll be having y is equals to 8 over 4x minus 5 over 4. 2 can go in 4. Sorry, 8 can go in 4 rather. So that gives us y equals to 2x minus 5 over 4. So now this has been expressed like the general equation of the straight line. So that means now our m2, which is representing the gradient of this equation, will be equal to what? 2 as well. So you can see that in this case, m1 is equal to what? M2. So that means that they are what? Parallel. This line is parallel to this second line as well. So also, example 4, we have to show that straight line y is equal to minus 4x plus 7 is perpendicular to the line 4y minus s. Sorry, 4y is equal to s minus 4. So also, what do? Find the gradient of this line. We find gradient of that line. We have y is equal to minus 4x plus 7. And this has been expressed like a general equation of straight line already. So, and that means our m1 will be equal to minus 4. Then from here also we can find gradient of this straight line as well. This one has not been expressed yet, so we need to divide through by 4. So we have y is equal to s minus 4 over 4. If you split this fraction, that will give us y is equal to 1 over 4s minus 4 divided by 4 give us 1. So in this case now, our m2 will be what? Our m2 will be 1 over 4. So now we have to show that they are perpendicular. That means the product of their gradient should be equal to minus 1. So m1, m2 will be equal to minus 4 times 1 over 4. 4 will take care of 4. That will give us a minus 1. So we can see that they are also what? Perpendicular, as we have been able to prove or show that they are perpendicular using the condition for parallelism and perpendicularity. So if you understand what we have done so far, you can try these 4 questions by yourself, and just freestyle with these 4 questions on the parallelism and the perpendicularity, and drop the answer in the comment section of this video so that I will relate with them for you. So next thing we want to do is that there are more questions that you could be asked on parallelism and the perpendicularity of straight lines. So there are still more questions that you could be asked apart from what you have done so far on parallelism and perpendicularity of lines. Now the first thing you can also do is that they can ask us to find equation of a straight line which passes through point -3,5 and parallel to line 3y minus 5x plus 2 equals to 0. What are we saying in essence? There are 2 straight lines. We don't know the equation of the first one, but we know the second one. So we want to know the equation of the first one, and we are told that the equation we are looking for is parallel to this straight line, and that equation is passing through these coordinates. So we have to find that equation. Now if you are smart, you should be able to think about what you are doing here, because the equation you are looking for is the equation of straight line. That means it's going to be a linear equation 1, and it's going to be in the form of y is equal to ms plus c. So all you need to do, all we need the gradient and we need the y-intercept. And because since we are told that those lines are parallel, that means if I can find the gradient of this one, whatever I get will also be the gradient of the straight line I'm looking for. So assuming that gradient of this one is 2, that means gradient of the straight line that I'm looking for is going to be 2 as well. So I'll substitute that 2 into the general equation of straight line. Then all I need to find next is the y-intercept, which I will use this coordinate to find. Do you understand that? Let's try to demonstrate that. So all we need to do is to first of all find the gradient of this straight line, which is the 3y minus 5x plus 2 equals to 0. And by now you know how to find gradient of straight line from the equation of the straight line. All you need to do is to make this equation look like a general equation of straight line. So, but it's not yet look like that. So you need to make y sort of the formula first. So take minus 5s and 2 to this side. You have 3y equals to 5s minus 2. Divide through by 3. You have y equals to 5x. So 5 over 3x, then minus 2 over 3. So in this case now, you will know the gradient of the straight line. So in this case, our m1 will be 5 over 3, which is the equation of x. So that means the gradient of this straight line is 5 over 3. And we are told that the equation we are looking for is parallel to this one. So if the gradient of this one is 5 over 3, that means the gradient of the equation we are looking for is also 5 over 3. So which you can call m2. You can say that the m2 is going to be 5 over 3, which is the gradient of the line we are looking for. So, and we are looking for that equation of that straight line, which is going to be in form of y equals to ms plus c. Then that means the gradient of that equation, which is m, will be what? 5 over 3. So put that here. You'll be having y is equal to 5 over 3x plus c. The only thing that we need to find next is the y-intercept, which is c, and that we can find using the coordinate of the point that the line passes through. So the line passes through -3,5. So in that case, at -3,5, our s is -3 and our y is 5. So put that in this equation. You will be having 5 equals to 5 over 3 into -3, which is our s, plus c. 3 will cancel 3 here. You have 5 equals to -5 plus c. Collect like times c will be equals to 5 plus 5. That will give us 10. So that means the y-intercept here will be 10. If you put that into this equation here, you have y is equals to 5 over 3x plus 10. So this is the equation we are looking for that is parallel to this equation here. And we can also clear this denominator by multiplying through by 3. So that gives us a 3y equals to 5x plus 30. So which is the equation we are truly looking for. Okay, also we have to find the equation of the straight line which passes through this point and is perpendicular to the line 2x minus 4y plus 3 equals to 0. it is similar to this question we just solved now, but the condition here is a perpendicularity, not parallelism. So also, what can we do? We are looking for equation of straight line that is perpendicular to this one here, and the straight line passes through this point. So we know the condition for perpendicularity. If I can find the gradient of this straight line, then I can use it to find the gradient of the second line I'm looking for. Then after knowing the gradient of the second line, I can now find the y-intercept. So how do we go about that? Let's find the gradient of this straight line first. We have 2x minus 4y plus 3 equals to 0. From there, we need to find the gradient of this straight line. Of course, you know what to do by now. We need to make y solve the formula before we can pick our gradient. So I can take minus 4y to this side so as to make it positive. So I have 4y equals to 2x plus 3. Then I can now divide through by 4. So that will give us a y is equals to 2x over 4 plus 3 over 4. So 2 can go in 4. That will give us 1 over 2. So we have y is equals to 1 over 2x plus 3 over 4. So in this case, the gradient for this equation or this straight line will be 1 over 2. So our m1 is 1 over 2. And the condition for perpendicularity is that m1, m2 must be equal to minus 1. Don't forget that. So our m1 is 1 over 2. If you put that here, so you have 1 over 2 times m2 equals to minus 1. So we can use that to find our m2, which is the gradient of the equation we are looking for. So you can cross multiply here, or you multiply through by 2. So if you cross multiply, you'll be having m2 equals to minus 1 times 2. So minus 1 times 2 will give us minus 2. So the gradient of this straight line is minus 2. Then, but we know that the equation we are looking for is a linear equation as well, which is going to take the form of the general equation of straight line, which is y equals to ms plus c. So the m is a minus 2. So if you put that here, you have a y is equals to minus 2x plus c. All we need to find is the c, which is the y-intercept. So we can use at this point that the line passes through. So at minus 3,5, it means that our s is minus 3. You need to put that here. Our y is 5, which need to put that here. If you put that, you'll be having 5 is equals to minus 2 times minus 3, which is x plus c. So that will give us 5 equals to 6 plus c. Collect like times c will be equals to 5 minus 6. C will be equals to minus 1. So this will be returned back to this equation here. So that will give us a y equals to minus 2x minus 1 as the equation we are looking for, which is perpendicular to this one here. So those are other things you can be asked to do with perpendicularity and the parallelism of straight lines. So if you understand what you have done, just try these two questions also by yourself and relate the answer with me, and I will check whether you are right or wrong. Now, the last thing we are going to be discussing under coordinate geometry is the angle between two straight lines. The angles between two straight lines. How can we find the angle that exists between two straight lines on the coordinate geometry? Now, to find the angle between two straight lines, we calculate the angle by tan theta is equals to the absolute value or the modulus of m2 minus m1 over 1 plus m2 m1. So where theta is the angle between the two straight lines, and the m1 and m2 are the gradients of the two straight lines we are involved in the question. So if I want to find the angle between two straight lines in coordinate geometry, I will use tan theta is equals to absolute value or modulus, which this two straight line means absolute value, which also means modulus of m2 minus m1 over 1 plus m2 m1, where m2 and m1 represent the gradient of the two straight lines, and theta is the angle between the two straight lines we are looking for. Now, there are two things you need to take note when it comes to angles of between two straight lines. Now, you need to note that when your m2 minus m1 is equal to 0, what does that mean? Look at m2 minus m1. When this is a fraction, the numerator, division, and denominator. when the numerator of this fraction is equal to 0, that is m2 minus m1 is equal to 0. When it is equal to 0, what can you say about this fraction? That means the whole fraction becomes 0. When the numerator of a fraction is equal to 0, that means the whole fraction becomes 0. So that means you'll be having tan theta is equal to what? 0. So that means theta will be equal to 0 as well. So you don't need to stress yourself calculating further. Assuming that my gradient here is 2 and this one is also 2, that means I have 2 minus 2, that gives us 0. So that means I should know automatically that theta will be equal to what? 0. How? Let's see. If I take this minus m1 to this side, what can we see? We see that m2 because of what? M1. And this is the condition for parallelism in coordinate geometry, if you remember. So in parallelism, m1 is equal to what? M2. So which is parallelism. And we know that two lines are parallel when they do not meet. And if two lines do not meet, that means there's no angle between them, if you remember also. So that is what you are trying to verify here. So when I have that the gradient m2 minus m1 give me 0, that means automatically the angle between them is equal to what? 0 degrees. So I don't need to stress myself because of those students that are writing JAMB. They can test you on this. Also, when the denominator, which is 1 plus m2 m1 is equal to 0, what can you say about the fraction here? What will it become? If you remember vividly in SS2 topic, there's what we call undefined fraction. I'm still going to be doing this video on those things also on that very soon. Undefined fraction. When is a fraction when does a fraction become undefined, or when is a fraction undefined? When the denominator of the fraction is equal to 0. So when the denominator here, which is 1 plus m2 m1 is equal to 0, what does this fraction become? It become undefined. That is, it become infinite. Undefined means infinite. So if become infinite, that means we'll be having tan theta to be equal to infinite. That means theta will be equal to 90 degrees. Theta will be equal to 90 degrees because tan 90 is also infinite. Tan 90 is equal to infinity as well. So tan 90 is also infinity. So if this fraction become infinity, that means theta is automatically 90 degrees. How? Let's see that as well. So if I take this one to this side, what can I see? What do we see? We'll be having m2 m1 to be equal to what? Minus 1, which is also a condition for perpendicularity of two lines, if you remember. So, and we know that if two straight lines are perpendicular, that means they will meet at angle 90 degrees, if you remember that as well very well under plane geometry. So two lines are perpendicular when they meet at angle 90 degrees. So we can see that of a truth that tan theta will be equal to infinity when the denominator is equal to 0, then theta will be automatically be what? 90 degrees. So if I'm finding angle between two straight lines and I discover that this is equal to 0, automatically I should know that the angle is going to be 0. Or if I put my gradient here and I simplify and the denominator is equal to 0, that means I should know that the whole fraction will become infinity. That means theta will be automatically be what? 90 degrees. Do we understand that now? So let's see how we can find angle between two straight line. The first one we want to do here is that we have to find the angle between line AB and line PQ. Given that coordinate of A is this, B, P, and Q are given. So we have to find the angle between them. So of course, we know that we need to find the gradient of line AB and we need to find the gradient of line PQ. So I want you to find the gradient of line AB, find the gradient of line PQ. You can pause this video to do that and see what you get. And after that, you can now play the video back so that to test your ability on that. So if you find you have gotten that line, let M1 be gradient of line AB and let M2 be gradient of line PQ. So to find the gradient of line AB, which is M1, you have y2 minus y1 over s2 minus s1, which is the formula for finding gradient. Your y2 is 3, your y1 is 1, your s2 is 4, your s1 is 3. If you put that into this formula, you have this. Simplify, you have that gradient is going to be 2. Then find gradient of line PQ. which is m2 equals to y2 minus y1 over s2 minus s1. Your y2 is 8, y1 is 6, s2 is 5, s1 is 4. Put that into this formula, we have 8 minus 6 over 5 minus 4. Simplify, that gives us 2 as well. You can see that m1 is equal to what? m2. That means the two lines are parallel, if you remember. So, but we are talking about angle here now. So tan theta is equal to absolute values of m2 minus m1 over 1 plus m2 m1. So we need to substitute the values here. If you put the values of our m1 and m2 here, m2 is 2. So if you put that, you have 2 minus 2. That will give us over 1 plus 2 times 2. So 2 minus 2 is equal to what? 0. So that means the whole fraction becomes 0. So you have tan theta equal to 0. Then find the tan inverse of 0. That means theta will be equal to tan inverse of 0. And that will give us 0. So even from here, you don't need to do this one. You can just say, look, that theta is equal to what? 0. Because the whole fraction is equal to 0. And because the two lines are parallel, the angle between them is 0 because there's no angle between them. Example 2 also, we are to find the angle between line XY and line PQ, given that line XY will pass through point S and point Y, and line PQ will pass through P and Q. So also, we need to find the angle between them, and I want you to, of course, we need to find the gradient of line XY, and we need to find the gradient of line PQ. Pause this video, find the gradient of line XY, and find the gradient of line PQ, and let's see what you get. After that, you can play the video back so that to check whether you are right or wrong. After doing that, let's m1 be the gradient of line xy, and let's m2 be gradient of line pq. So to find gradient of line sy, which is using the formula for finding gradient, our y2 is 4, y1 is 2, s2 is 2, s1 is 3. If you put that into this formula, we have this 2 minus open bracket minus 1 over 3 minus 5. Then if you simplify that, will give us minus 3 over 2. Then for the gradient of line PQ, which is M2, we call it M2. Put the values here. You'll be having 6 minus 4 over 5 minus 2. If you simplify that, give us a 2 over 3. So our aim is to find angle between them. So tan theta will be equal to absolute values of M2 minus M1 over 1 plus M2 M1. If you substitute the value of your gradient here, you'll be having tan theta equals to 2 over 3, which is M2, minus M1, which is minus 3 over 2, over 1 plus M2 is 2 over 3, into bracket, minus 3 over 2. Then if you simplify that further, minus times minus will give us plus here. You have 2 over 3 plus 3 over 2, over, if you open the bracket here, 2 will cancel 2, then 3 will cancel 3, so you are left with 1 plus minus 1. Minus times plus will give us minus, so you have 1 minus 1, that will give us what you're having here. And 1 minus 1 will give us what? 0. So that means the whole fraction here becomes infinity. So that means we having tan theta to be equal to infinity. Then that means theta will be equal to 90 degrees. So theta will be equal to 90 degrees, because if you find tan 90 is equal to infinity as well. So the last question for today is to find the angle between this line and the second line as well. So in this case, you are given the equation of two straight line to find the angle between them. So also we need to find the gradient from the first line. We need to find the gradient from the second line as well before you can put it into the formula for finding angle between two straight line. So let's find the gradient of this one as well. You can pause the video and find the gradient by yourself, so as to know whether you can find the gradient of straight line from the equation of the straight line. Then having done that, of course, you know that you need to make y sort of the formula here before you can find the gradient. So take 3x to this side, you have a 4y equals to minus 3x plus 2. You can now divide both sides by 4. You'll be having y is equals to minus 3 over 4x plus 2 over 4. Then from there, we can now deduce our gradient from here now. So our m1 is going to be minus 3 over 4. And also for this second line as well, we have that our x minus 2y is equals to 3. So we also need to deduce the gradient from this equation of straight line. So we need to make it look like a general equation of straight line by making y sort of the formula. So I can take minus 2y to this side. So I have minus 2y, I have 2y equals to and then minus 3. Then divide through by 2. We have a y is equals to 1 over 2s minus 3 over 2. So that means our m2 will be equals to 1 over 2 as well from this equation. So to find the angle between them, you have tan theta is equals to absolute values of m2 minus m1 over 1 plus m2 m1. So if you substitute the value of m2 and m1 here, you have tan theta is equals to 1 over 2, which is gradient of the second line, minus m1, which is gradient of the first line. So we have 1/2 minus open bracket 3 over 4 over 1 plus 1 over 2 into minus 3 over 2. Having followed this formula, then you need to simplify further. Minus will give us plus, then open this bracket as well. So if you do that, we have 1 over 2 plus 3 over 4 here over, if you open this bracket, you'll be having 1 times 3, that gives us 3, 2 times 4 gives us 8. So we're having plus times minus will give us a minus. So you can find the LCM by simplifying this, and you can also find the LCM by simplifying this as well. So if you simplify this by finding the LCM, that will give us a 5 over 4. Then divided by, if you simplify this one also by finding the LCM, that will give us a 5 over 8. So this can be written as a tan theta equals to absolute values of 5 over 4. This division sign can be written as a division like this, 5 over 8, which you cannot change this division to times. So that will give us a tan theta is equals to 5 over 4 times 8 over 5 by inversing this to change this one to times. Then from there, 5 will take care of 5, 4 can go in 8, that will give us 2. So tan theta is going to be 2. Then to find theta here, you need to find the tan inverse of 2. Theta is going to be tan inverse of 2. Theta will going to be 63.4 degrees as the angle between this line and this line. So we have demonstrated how you can find angle between two straight lines, and if you understand that, and if you remember the formula for finding the angle between two straight lines, try to find the angle between these two pairs of lines for these 3 questions, and you can drop your answer in the comment section of this video so as to evaluate you on that. So that is all we have for you concerning coordinate geometry. And let's do a brief recap. We talk about how the meaning of a coordinate, where you can get coordinate from, and we talk about distance between 2 points. We have talked about the midpoint of 2 points also. Then we talk about how you can find different ways of finding gradient of straight line, whether from the graph or given the 2 points that this straight line passes through, or whether from also from the equation of the straight line itself, we can also find the gradient of a straight line. Then from there, we move to how we can find equation of straight line, and we talk about different ways of finding equation of straight line as well. And also we now talk about the parallelism and perpendicularity, and we talk about the conditions that must be satisfied, and we use this condition to solve questions as well. And from there we talk about the angle between two straight lines. And I want to believe you have learned 1 or 2 things from this video, and you believe you understand some of the concepts that we have discussed. If you don't, please go back to the video and review the video once again. You will surely understand, and please lay your hands on those evaluation questions so that you will know whether you are doing the right thing or wrong or not. So before we go, please, if you are here to subscribe to this channel, please click the subscribe button on the channel right now so as to help us improve this channel, and also to help us improve this video. And don't forget to share this video with students out there who are going to be writing exam very soon, and students who are still in school as well. Don't forget to give a thumb up for this video, and share and like the video, and I will see you in the next video. God bless you. Bye.